In this example, we're going to look at some composite functions and their domain exclusions. So to begin with, I have two functions, f of x and g of x. And here I want to evaluate f of g of x. And we could also write that as f of g of x. All this means is that in function f, we're now going to input g of x. This is now our value that we're going to fill in. So I'm going to go to my function f, 2 over x minus 1. And wherever I see my x value, I know I need to fill in g of x. So I'm going to say 2 over, instead of x, I'm going to fill in 3 over x. And then I go ahead and rewrite the minus 1. Okay, now we need to simplify this complex fraction. So to do that, I'm going to multiply this whole problem by x over x, which is just like multiplying by 1. X divided by x is 1. That's why I'm allowed to do that. So let's go ahead and multiply the numerator. 2 times x will give me 2x. And then when I multiply the denominator, here I'm multiplying 3 times x, which gives me 3x still over x. So my x's here will cancel. Leaves me 3, and then x times negative 1 is negative x. So function f evaluated at g of x gives us 2x divided by 3 minus x. Alright, so now we're going to be looking into trying to determine where the domain exclusions for this function are. And the first thing we need to do is look at the input value. So we want to make sure that our input value isn't going to give us any solutions that aren't real numbers. So I know I can't have any division by 0, and I can't have any of those even roots of negative numbers. If I look here, I have division, so I can't allow x to equal 0. So I already know that x is not allowed to be 0. I also need to look at my composite function, f of g of x. And I need to make sure that none of these occur as well. So let's make sure that the domain does not give us 0 in the denominator, so we're not dividing by 0. So I know that 3 minus x is not allowed to equal 0. So let's figure out when that happens. To solve this, I need to subtract 3 from both sides. It leaves me negative x equals negative 3. And then I'm going to divide both sides by negative 1, which tells me that x equals positive 3. So these are the two values I'm not allowed to have. X is not allowed to equal 0, and x is not allowed to equal positive 3. So let's go ahead and write out our domain values. Okay, we know that we're going to start at negative infinity, and then the first value that's not allowed to be in our domain is 0. So we're going to stop at 0, not including it because it's not included in the domain. Then we need to start again, anything greater than 0, all the way up to 3, where we must stop again. And then we're going to start back up at 3, anything bigger than that value, and go all the way to positive infinity. And for this next example, let's go ahead and use our same two functions, f of x and g of x. But this time we're going to find, instead of f of g, we're going to find g of f of x. So we're going to write g of f of x. So the only thing that's going to change now is that we're going to start with function g, and we're now inputting function f. So I'm going to use function g, 3 over x, and I'm going to input wherever I see that x, I'm filling in function f. So 2 over x minus 1. Now this looks quite a bit messy here to me because I'm dividing by a fraction. So instead of dividing by this fraction, I'm going to multiply by its reciprocal. So instead of 2 over x minus 1, I'm going to flip that fraction and make it x minus 1 over 2. And now I should be able to multiply. 3 times x minus 1. I'll distribute that 3 and get 3x minus 3. And then I know that there's a 1 down here, so I have 1 times 2, which just gives me 2. So this time function g evaluated at function f gives me 3x minus 3 all over 2. So let's look at our domain exclusions for this function. To begin with, I need to look at my input function. Okay, and then this time this was function f. So I need to make sure that I don't have any of that division by 0, and I don't have any roots of negative numbers. So let's check and make sure that doesn't happen. If x minus 1 isn't allowed to be 0, let's figure out where that would happen. I need to add 1 to both sides. So I know first of all that x is not allowed to equal 1. And then I need to look at my composite function, and I need to make sure that none of these things occur here. Well, I don't have any division by 0 because I just have 2 in the denominator. And there are no square roots, so I'm not going to have the even root of a negative number. So our composite function is fine. So our only domain exclusion is at x equals -1. So let's go ahead and write out our domain. We're going to go from -infinity, and the first place we have to stop is at +1. We're not allowed to include 1. And then we'll start back up with all the values that are larger than 1 and go to +infinity.